I had a meeting with your TAs a couple days ago, not not about anything that happened, but because I wanted to check in, so they knew what needed to be done for the final project, and I know you still need to know what needs to be done. So don't worry, I'm getting to that today. Okay. But they brought to my attention that a lot of you are feeling very behind in your work and you're feeling very stressed. So, and I admit that I have fallen into the trap of, oh, we're back in session, so I can treat this class as normal. I mean, in terms of my expectations. But at the same time, I'm receiving multiple emails, like it feels like one a week at this rate, of a student telling me that they are missing class because a family member has died. This is not a normal semester, and I understand that. We all like to delude ourselves into thinking that, conditions are normal. Because that gives us a sense of safety and security. But there's still a pandemic going on. And I'm aware of that fact. So please let me know, and I understand if you're not comfortable in saying that you're having difficulty with the class in chat, but please let me know that, like, if my deadlines are like driving you insane, because my expectation is that students don't suffer silently, but I realize that the amount of stress that you may be under may not do that. Now on the plus, so please, if you need extensions on my deadline, that is something that is easy for me to do, So I understand that. Now, how much time are you going to be able to work on your independent project? Well, the answer is that I'm not really releasing any more mandatory labs, any more lab assignments after this. Basically, our devotion is going to be towards the final project. Now, you are definitely won't be the only one behind. There might be some readings, depending on the lectures I do. I might do some readings like on sorting, but probably just readings. I do plan on giving one more quiz, so a quiz 6. However, I do plan on dropping the lowest quiz grade. So, So yes, I can give. So yes, I can give you more time on the pig lab. I will give an extension on that. The pig lab is the last lab assignment lab. There will be another lab there will be some extra credit labs available. Okay. One for regular expressions, which I do highly recommend you do because it will make your final exam easier. But it's not going to be required. Okay. Yeah. And quiz? Likewise, the quiz will be, there will be a quiz 6. Yes.
Quiz 4 is due on the 29th, right?
Right. I had meant to make it due on Sunday, but because I had already accidentally set it to the 29th, I'm keeping it at the 29th. So be please aware that that quiz 4 is due the 29th, and then you've also got a quiz due on the 1st.
Okay, thank you.
Okay. Yes, if you have missing exercises, just please go back and do them. If you've done them, if you think you've done them and haven't gotten credit, send me an email because we should resolve that at this point. Okay. So, but for the most part, starting November, let's see, let me take a look at the calendar. Most of our time will be devoted towards basically working on the final project, as well as but in class, I'm going to cover like extra topics. The recordings from last week I uploaded, I think either yesterday or the night before, and they've just been attached to the for last week, I've just simply added them to the playlist. So I didn't upload anything new. I just simply added to the playlist stuff from last semester.
Thank you.
Okay. What are the file readings on quiz 4, dictionaries on quiz 5? Now, the only thing that I'm not going to be so there are some hard deadlines that I don't adjust. Which is the deadline for the quizzes. Quiz 5's corrections will go out on the 29th. There is one thing that we will cover on, so let me talk about the final. So that's a great question. I'll go ahead and talk about the final exam for a second. There are 3 questions on the final exam, as I see it. Also, the final exam will be done online, which means that what that means is essentially that everybody's going to sign into Zoom session at the same time, and I'll be available to answer your questions. I'm not going to use Proctorio or any of that nonsense because I don't need it. I'm good at catching cheaters without it. More in detail on that later. But the 3 questions I will ask you, I'm going to go over the proposal stuff. Okay. That's what I'm going to go over today. The proposal, I'll go over that with you. Okay. So, the final exam, we will have a question along the lines of this. This is a question I've given on a final exam a number of years ago. Here's a file that has a bunch of text, including some social security numbers in it. I would like you to go through it and replace all those social security numbers with the word redacted. In other words, I want you to, remove all those social security numbers from this text file. Now, I will show you how to do that, how to solve that exact question. A couple years ago, it was something along the lines of email addresses to do that. This becomes an easy, now you can do this without regular expression, but it becomes hard. I think it's like, I think it's 20% is the final exam. And also, so I will go over that with you in the final exam, and there are like different things, like you get like X amount of points for opening the file, X amounts of points for reading the file, X amount of points for correctly identifying any string that looks like a social security number, X amount of points for opening a file or write it, X amount of points for writing. So I kind of bullet point all the objectives that you have. So you can rack up partial credit. So while it is one question, there are the parts to it. Now, mind you, if you've been thinking about that, you're like, wait a second, I can do most of those in one line. And the answer is correct. If you know what you're doing, you can do a lot of that in one line. A lot of those. Is there a time limit to the final? Yes, yes and no. I will get into that. There's a late penalty for the final exam for people who need it. So, but at the same time, you might not have the time afterwards to complete it. So because of scheduling stuff. So contact me if that's the case. Give me 1 second. The final exam, it's not like I'm going to be anywhere doing anything that I need to do. So other than proctoring. So second question is, I will introduce some new knowledge to you. And I will ask you, like, here's a thing you haven't seen before in class. Please, this is how we use it. Please solve the problem with this new thing. And finally, question 3 is, here's a game. Please do a Monte Carlo simulation on it and tell me how often the players win. Now, what happens if somebody's caught cheating on the final? I submit a academic dishonesty form. And depending on the extent of the on the cheating, I send that in. I recommend either a failure on the exam or a failure in the course. Now, I had to do a number of those in the spring. Between my 2 classes, I had about 12 forms to fill out. That was a lot of paperwork. The final is open everything. Open note, open book, just no communicating with other humans. I will go into the rules about that. Now, and a large part of this is because students Googled for one of the questions. They Googled it. They found the first result and they grabbed the code for the first result without realizing that A, it uses lambda expressions, which is something that I didn't teach in class. So they had no idea what those do. B, it uses list comprehensions, something I didn't teach in class, so, which is something they have no idea on how to do. C, it covered the wrong thing. It did not actually address the question at hand. It looked at it, but the parameters being for that were different. Yes, you can use techniques outside of class, and that's fine. And last thing, none of them cited their work.
So if they cited their work, would they have gotten a 0?
They might have gotten a 0, or I might have told them to redo the question, but I would definitely not had to have submitted an academic dishonesty form for plagiarism, because it wouldn't have been plagiarism. You cite code by telling, if you get code from somewhere, put it in the comments that you got it from somewhere. That way you're not performing plagiarism. Nisa's got it. It depends. Yeah, list comprehension is perfectly fine if you know how to use it. It's just one of those markers that I go and look and see, wait, did this code appear online or something? No, you don't have to cite your own code that you write. You don't have to self-cite. That's a great question.
What if you are collaborating with somebody, not on the final, but like on a different assignment, and you use some of their code?
Totally cite it. Be honest and
Oh.
open with me. I'm not going to be a jerk about it. I encourage collaboration. I try to encourage collaboration between you guys, y'all. Okay, but I'm not going to be a jerk about it. If you're open and honest with me, you're not performing plagiarism. You're not performing academic misconduct. The worst I'm going to do is tell you, please do it again, or please come back to me and get credit when you can fully explain it. Very informally for this class. This is not MLA or anything like that. If it's something online, you just simply give me a link to where you found it online. If you've worked with somebody else, you just simply say in a comment, I worked with this other student on this. Very informal here. And that has to do with the limitations of source code, and basically the more I ask you to do for citations, the less likely it is that students will actually follow through for it. So getting a link is the easiest thing you can do for it. So, okay. So, just be aware. And again, it wasn't so much the fact that I said, it wasn't so much the fact that they grabbed code. It's the fact that they didn't cite it, and that the code they looked for did not address the problem at hand, that they just simply blindly copied and pasted the first thing that appeared. For example, this is kind of like, suppose that you're trying to simulate the game, the popular train game, Ticket to Ride Junior, okay? For kids. So that's a variation of Ticket to Ride. Ticket to Ride Junior is an easier version of the game Ticket to Ride, made for kids. But the code they found was for Ticket to Ride, the adult version, which is different and more complex. So they didn't read the code or the problem prompt, and they just blindly copy pasted it. Make sense? That's what gets me angry and got me angry. Okay. So now, what day is the final? I'll figure that out. But if you need to look on your schedule, please look for the 3-hour course. Yes, this is a 4-hour course, but look under the 3-hour courses, because we are 3 lecture hours, not 4 lecture hours. And that's how we determine when the final is. So it's on the final exam schedule. Make sense? Okay, so why don't we solve that right now, since that got a question mark. And because this is also a good time to talk about your rights as students when it comes to final exams. You have those. You have rights as students. I know, I was astounded to find that out myself when I was a student. Okay, so final exam schedule Temple. So that's how I find it all the time. I just simply go to the registers site via Google. Okay, so I believe this is it for 2021. So which the last day of classes is Monday, December 6th, which is incidentally when your final project is due. The reason it's due on December 6th is because that is the latest I can push back a due date. Make sense? Okay, so our final exam, we look at the 3-credit courses because while we are a 4-credit course, we have 3 lecture hours and 1 lab hour. So we look under this time because we won't find our class time if we look anywhere else, if we try looking somewhere else. So here, right, we look Tuesday, Thursday, right? We look Tuesday, Thursday from 2 to 3:20. And so our final exam is, according to this chart, Tuesday from 1 to 3 o'clock, 12:14. Okay, makes sense? That's when our final exam will be. Okay. Now, does anybody know how many finals you're allowed to take in a day?
3.
2. Instructors are encouraged to work out individual accommodations with students who have more than 2 examinations scheduled in one day. Instructors with special scheduling circumstances should consult well in advance with their dean. So in other words, if your instructor is making up their own final exam time, they need to have gotten approval from the dean well a while ago. But regardless, if you have more than 2 final exams in one day, right? So if you have 3 finals or something, email me so that I know and so that we can figure out who needs to move. It's very easy for me to proctor the final exam for you at a different time. Okay. But that's another thing. Also, they can't give you a final exam during the study days or during the last week of classes. Final weeks is for final exams. Okay.
To be fair, as students, I don't think we're complaining too much if they're spread out a little bit more than 2 days after each other, you know.
So when it comes, so another thing, that means that since your thing is due December 6th, I'll have your the best final projects by the end of the week for that, so that you'll know by the weekend whether or not you have to study for my final. Okay.
Professor, I have a question about
Go ahead.
the exam questions. I mean, exam date. Can they give an exam during that final week as long as it's not a exam, like final exam?
Yes, I
Okay,
believe so.
thanks.
I believe so. So, okay. Your final exam, we'll talk more about that and I'll do a couple of review sessions before it. Okay. So I will go over questions that will be similar to things that I will put on the final. And I missed a bunch of stuff in chat. So, all right. So let's go ahead and now talk about the final project. Okay, the final project basically has 4 stages to it. Okay, the first of which starts today. Which really shouldn't scare you too much once you learn what it is. So here we go. The first stage is the pre-proposal. So what you'll find if you go over to this page is that there is a preproposal.md file. MD stands for Markdown. It's like a simplified version of HTML. I go ahead and you'll want to open it in a text editor of some kind, either VS Code, or you could probably open up an idle and it would work. Give me a second. Why isn't this opening in? Open. Yeah, my computer's just decided to boost up its fan to the highest level for some reason and completely ignore what I'm asking it to do. Not really sure what's up with that. Okay. Yeah, really not sure what you're doing. Don't save. Save file. Let's see, desktop. Yeah, I know I'm not showing you what I have at the moment. I'm just very curious as to why it's not opening in the text editor. Open with VS Code. Okay, there we go. No idea what was giving my computer so much difficulty. Maybe it was just trying to show who was boss. Yes, Amul.
You're not sharing your screen.
I know.
think.
I have got to switch my screen. Thank you. Thank you, though, for double checking with me. It's always good to assume that your teacher may not be aware. All right, so here you go. This is the proposal. This is what you have to fill out. It's part of your credit for your final project grade. So it's just 3 questions you have to fill out. What ideas do you have for your final project? If you plan to collaborate with 1 or 2 of your classmates, who are they? And do you have any questions of your own that need to be answered by me or that you need to go and answer as doing part of this? It's very simple. Now, this is just a markdown file, which gets rendered pretty nicely by a lot of web stuff, especially on GitHub. My plan is that on the 2nd, next Tuesday, I will try to devote as much time as possible as I can to quickly going through and speaking with different people and basically listening to what your idea is and telling you whether it's a good idea, a valid idea or not. Okay. So that's my plan for next Tuesday, to go through and kind of say, so what did you kind of propose? Okay. Because this is before we commit to it. Okay. This is just kind of your brainstorming. All group members have to submit one. Yes. Everybody has to submit one. Then after that, what you'll do is the proposal, which will be the same thing. I'm going to download it. And this is what the proposal looks like. Yes. No, the ideas do not have to be the same, but when you do the proposal, they will have to be the same among all the group members. All right. So what will be the title of your project? Yes, you can open it in text edit. Yeah, you can open in any text editor. So what will likely be the title of your project? In a sentence or 2, summarize what you're doing. In a paragraph or 2, detail what will your software do? What features will it have? How will it be executed? Are you planning on combining this course with another course's final project? Which you only have to do if you're answering yes to that. Who are they and who are they working with, and who are you working with? And then the other part, which is the kind of so notice that over here you are setting out the expectations for your project. My rubric is fairly straightforward. I will go into that in a second as to how you get an A on this. I would not use Word. I would use a text editor, like Notepad if you have to. Okay, but you'll see that you'll actually see that when we go into the Git portion of this lecture, we can edit this online, no problem. So if you're struggling, just hold on and listen, and we'll be able to edit it online in a bit. Okay. If you have multiple ideas for the proposal, yes. And then we can help you figure out which one is the most viable. So notice that in the world of software engineering, everything takes longer than you'd expect. You spend 90% on it's the 90-10 rule. You spend 90% of your time on 10% of the work. In a good sentence, define a good outcome for your final project, i.e., what are you going to accomplish no matter what? In a sentence, define a better outcome, i.e. what do you think you can accomplish? And then finally, what is the best outcome? What do you hope to accomplish? These are kind of your expectations for yourself. But that's not necessarily what I'm grading on. That's just to make sure that for us to read and make sure your expectations are realistic. And then what do you have to do next? So how do you get a A on this final project? It's actually not as scary as it seems, because everybody is at a different point in their programming career and everybody's at different levels. And I judge you by the journey you make, not the destination you end up at. Okay. Your final project, what you submit for this is that you will submit on GitHub. I will alter this to make sure that everything's on GitHub except for the video. What you're going to do is you're going to create a video that's like a demo, because scheduling this for everybody after the semester ends is kind of no, that's not going to work. You're going to do a video, a screencast. If you don't know how to do that, I'm doing a lecture on OBS at one point, so don't worry. And I'll show you how to do that. Your video should include all these details and stuff, and it should be a general overview of your project. Less about your code and more about what the awesome thing you built is. Okay. And we're interested in what challenges you encountered during coding and if you found a way to overcome them or go around them. We understand it may not be possible to complete your original vision. We're interested in how you responded in the face of adversity. The guidelines for an A are that it amuses me for a minute, amazes me, or makes a positive impact to the world, no matter how small. That's it. That's all you have to do to get an A. Amuse me for a minute, and I'm easily amused. Trust me on this one. So that's a pretty low standard for a game. Amazes me or makes a positive impact on the world, no matter how small that impact is. Okay. So, so I've just mentioned this a couple times that your project will be hosted on GitHub. What is GitHub? Okay, so first off, to answer that, we have to answer what is Git. And before we do that, we have to answer the question of who is Linus Torvalds. Okay, so let's go to Wikipedia, because I love Wikipedia, as I've mentioned multiple times. Okay, so Linus Torvalds is a Finnish-American software engineer. This is Linus Torvalds. He is responsible for Linux, the Linux kernel. If you are using an Android phone, it uses the Linux kernel as part of it. Okay, it's named Linux because he likes naming things after himself. It's based off of the Unix operating system, which is the same operating system that Mac OS is based off of. If you haven't learned Linux yet, you eventually will as a programmer. It's just inevitable that you will learn how to use a Unix-based system. Okay. He also named Git after himself, which, if you understand that, and for those of you who are unaware, Git is an insult. So he does have a sense of humor about his own self. So Git is a distributed version control system. So this distributed just means it's on a lot of computers. The version control is what's interesting. Version control is basically that there is a, you're gonna make me draw, aren't you? So give me a second to new share. The idea behind version control is that software development is tricky. Okay, so I might start with are you able to see my whiteboard? Okay, you might start with this kind of point, version 0.01 or something like that. Okay, and then you'll do a bit more work, and then you'll get to this point. And what you do with version control is you save a snapshot of your work. Basically, you track how it's changed. It's not just hitting Control S to save your work, but literally there's a snapshot that you're able to roll back in a backup. Okay. Are you able to see what I'm drawing?
No, we can't see the drawing.
It's
Okay.
just the way.
Well, it's, my drawing's crap anyway, so. So the idea here is we've got basically maybe a version, and then we create another version, such as a snapshot of another version maybe 0.2. And then we do another snapshot. And the idea is that if we irrevocably break our code, I could roll back to this point, to this snapshot, and continue on from there. I can also go back and see how things have changed. But, and here's the crazy part, I can also branch off. I could work, somebody could work on one portion and make their own and add their own features and own functions and work on one file where, and then somebody else can work on their own stuff over here. And then we can, you know, come back together and merge them together into one thing. Except that I've kind of run out of screen space. Now there's a lot of different kind of, there's different ways to do this. Git is, I think, possibly the most popular these days now. Now it may seem complicated, so let me go ahead and show you the reality of Git. This is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them up to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. This is more accurate, so accurate it hurts. So you can acquire Git over here to use it via the command line, just going to git-sem.com, but you may not need to do that. Before you do that, I would hold off because there's also a GUI application specifically made for GitHub that makes it all simple. What is GitHub? So GitHub got acquired by Microsoft a few years ago. They were already pretty big, but essentially it is a place for you to store your code using Git for free. Pricing, plans, free. So unlimited private and public repositories, certain amount of storage and automation on it. It's fine for what you need. This is perfect. And there's educational stuff too. It is used by, and it is fairly easy to use because you can download something, you know, a program, which I'll show you how to do this. So, so let me show you how this tracks changes. So first thing I'm going to do is I'll sign in. Okay. If you don't sign in, you'll create an account. I've got mine with two-factor authentication because it's important for me to do so. And I highly recommend setting up two-factor authentication. So give me a second. 1, 2, 3, 4, 5. That's the same combination that's on my luggage. I may have dated myself by referencing a movie made in 1987. You don't understand the purpose of Git because your save, it's like a super save. And more importantly, it allows you to work with other people without like destroying all the work that other people are doing. So let's go ahead and create a new repository. So projects are called repositories. So I'm going to go ahead and just create one. I'm going to call it fall 2021 example. You don't have to have a unique, your name doesn't have to be different than anybody else's. It just has to be unique for your account. So description, example for lecture. Private, meaning anybody can see it. Sorry, public, meaning anybody can see it, versus private, meaning that only you can really see it. And You can choose who can commit. What does commit mean? That basically means who can make changes. You do not have to use a Git. You do not have to use a GitHub. You are allowed to use a different Git service, but you do need to store it on somewhere. I highly recommend GitHub. How'd you make it? You go to here on your start page. You go here, click new. So I clicked new, and that brought me to here. I typed in the repository name. Going to make it public. And let's go ahead and initialize it with a README file. Always a good idea. Choose a license. We'll learn more about licenses later, but essentially your code has copyright status. It's important to choose a license. In general, the MIT license is probably just generally a good one, but this is more toward worth its own sub lecture. Okay, so I'll go ahead and don't worry about the other stuff with the git ignore. That just tells it to ignore files. So create a repository, boom, and there we go. I've got my initial file and my initial commit. Now notice that it is a .md file. Okay, a markdown file. In fact, what I can do is I can actually just upload files to this repository. This is generally not how I do things, but just kind of as an example, I want to show you that I could just upload the proposal up here. And then commit changes. And boom, now the proposal's up there. Okay, and so now notice this counter has gone up. It's saying the thing has 2 commits. The initial commit where we didn't have the file, and this initial commit now where we have added this second file. So it saves a snapshot of it. So let's go ahead and say that I want to edit this. Okay, now, yes, we can't do this all online, but I'm just showing you can over here. Here, notice that the proposal has kind of changed. If I go to raw, I can look at the raw text for the file. It just understands the hash marks and modifies, and so modify this file. So notice that anything with a hash becomes headers and subheaders. What ideas do you have for the final project? Let's see. A fifth movement for Dvorak's Ninth Symphony from the New World. You're like, that's not a computer science thing. Generated by AI. Now it's a computer science thing. Okay. Mod for Stellaris. Video game. Let's see. A laser tripwire that sends me an email. One I suggest, by the way, if you don't have an idea, that's a good one to do. Okay, and so then I can simply say, put down some ideas so make a note of what changes you made and commit directly to the main branch. And now we'll see that basically a history that we had nothing at first, just to do. And now with the newest thing, it's been replaced by this. I've added these ideas over here. Now, mind you, we can't do everything through here, but you certainly can for your first assignment. So how do we go about doing this? Because a lot of code is hosted on GitHub. Well, I'll typically use GitHub to do this. Notice that it says open with GitHub Desktop. That's not what I'm going to do right now. So what I'm going to do is I'm going to go ahead and share my entire screen. Okay. To show you how to use the command line to do this, which is the hard way. And then I'm going to show you the really easy way. Okay. So I've got this now. Okay. And what I'll do is I'll open up my command line. And I've installed Git by going to this website and just following the instructions. Git SEM and Git-SEM. I downloaded for Windows. I clicked default on everything. And so it worked. I downloaded the file and I was able to open it up in my terminal. No worries there. Okay. So I'm going to go to my desktop so you can see it appear. CD desktop. CD is short for change directory. So I was in my user folder. So now I'm saying I'm on my desktop. So Git has a number of commands all listed here. The first thing you do to get a copy of what's online onto your computer is to use the Git Clone command. And the way that works is you use Git Clone and then you say the address of whatever you want. So you go over here and you just copy this URL over here, hitting this button. This is the hard way to do it, remember. So Control V over there to paste it in, hit enter, and it says cloning into this. And now open this up, open up this file. And you'll see that there are, and let me zoom in. Notice that I've got a couple files. I've got this blank README file. I've got this proposal file. Right? And it's got the text that I put in from online. Okay. Okay. Now, suppose you take a day off from programming and you're working in a project with somebody. Okay. Now, and then somebody makes changes to the code. Okay. This is where it gets nice and fun. So suppose somebody on their own computer, as opposed to being on here, adds their own idea, which is building a Tetris game, but with lasers in outer space and pirate ninja robots to make it extra cool. Right. So suppose that your partner adds this. Right. Well, how do I update my file here? How do I update my file on my local copy? I use a command called Git Pull. Git Pull gets I have to move into the directory I just cloned. So Git CD fall 2020, one example. So now what I use is the command Git Pull. And it's going to check online and say, hey, did anything change? Yes, it did. Okay, great. We change, and then it makes the changes over here. Now, there's probably leads some of you to the question of like, what if I change something and what if he changes something? It will solve that, but let's first learn how to change something on our own. Okay. So let's go ahead and say, so I want to go ahead and, so let's go ahead and go into this file again and make our own changes and upload them. Notice that my file changed over here. Pretty cool. Also known in VS Code that if I hover over here, it knows that I'm working in a GitHub and it has buttons specifically for working with GitHub. A lot of file editors have GitHub stuff planned in. So I'm going to go over here. I want to work with Alice and I'll put not really. All right. So I'll save the file over here. Now, so what I can do is again, anytime I make a change to a big change to a file, what I want to do is I need to commit it. I want to save it on GitHub. It's a two-part step. One is to commit it. Committing is making that snapshot. You do one of two things commit. You say git commit, and then the file you changed. So if you just want to like, if you've changed multiple files, but you just want to you've changed multiple files, but you just want to talk about one, you can just simply put in the name of the file. I generally never do that because the projects I work on are fairly small. I just simply say git commit -a, and that just simply says, make a snapshot with all the changes that I've made so far. And then over here, it pops up with a message in Vim. I hit enter. That's a whole different story. Look up how to use Vim if you get into this window. So I hit I to go into insert mode and say, added Alice to the project. Okay. Then colon right quit to save. And now that's been a local change made at 250. Okay. But that doesn't update what's over here. Okay. In order to update what's gone on the web, I have to push. I pulled the changes so that were made. So now I'm going to push the changes. These are basically the 3 commands you need to know. Oh, sorry, 4 commands you need to know. Clone to make a copy. Pull to get a file, to get something online. Push to push any changes you make, any of the commits you make, and git commit to make the snapshot. Will this be on an exam? No, it will not. It's just such a useful tool. You should learn how to use it. And it's just part of, and again, your project has to be hosted on GitHub. So it's worthwhile to learn. Now, that being said, again, this is the hard way to do it. And I'm just showing you the hard way to give you an appreciation for the easy way. So here it wants me to sign in. Great, done. Boom. Oh, I only have to do that once. And now if we go over here, remember I made my last change at 850. Sorry, at 250. I'm going to refresh the page. Says, here, added Alice to the project. And so now the change has been made. Alice has been added to the project. So now I'm going to go ahead and say, so let's go ahead and do some stuff over here. So I'm going to go ahead and make a change over here and say, Bob also is going to be on the project. Okay. Now, Bob isn't his proper name. It's actually Robert. So Alice on her own computer, and again, pretend I'm on Alice's computer for the sake of this. She goes into and modify the proposal because she sees I haven't made a change yet and goes Robert instead. Okay, so she'll make a commit. Robert. Commit changes. Save over here. Okay, and what I'm going to do now is, again, I have to go CD desktop because I was silly and close the CD fall 2020. Okay, git commit. So notice here I did not pull the latest change. This is intentional on my part. Added Bob to project. Okay. Git push. Actually, I don't want to push yet because you don't have to push after every commit you make. Let's suppose that now also we've been filling this out. So I'm going to start my project, which is, suppose we decided on Tetris, but with lasers. Okay. So I'm going to make that file Tetris with space lasers.py. Okay. So I've made a new Python file right there. Okay. Print. And I'm just going to do print hello to make sure that's not empty. Right. But I just want to get the file so we can get started with it. Make sense to everybody? Notice also that it's green up here and a U. This is, I think, a way of it saying that, hey, it's a new file. But anyway, to add this, okay, I lied. One more command, a 5th command, git add dash it. So I'm going to git add, and I'm going to say what file I want to add to the project. You tell Git what files you care about, what files you want to keep track of. So I'm going to say the Tetris with space lasers file. Please keep track of that file. And then git commit to basically make a snapshot now that we have it in. And see, it says in here, new file. Okay, so added the, oh, sorry, I'm going to say create the Python file. So, okay, git commit. So we've committed. Great, I've made my changes. And so now what I'm going to say is git push. So I'm going to upload my files to the server. And now notice what it says. It may be hard to see. It says rejected, failed to push some references. Hint, updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same reference, same ref. You may want to integrate those changes again first. No, e.g. git pull. It's telling you do a git pull first. What it's saying is that that essentially I am missing the change that was made over here, and that's not been integrated into my thing. So I need to rectify that. So, okay, git pull. Now, most of the time this gets solved automatically, but I've set it up so that there's going to be what's called a conflict. Most of the time, the merge gets sorted automatically. Now it's saying the automatic merge failed. So if we go to my proposal file now, it's been changed. And notice that basically it says, here's the difference. One file says Alice and Bob, one file says Alice and Robert. Like a lot of times if I add a method and you add a method and they're named different things, it's smart enough. It figures out, oh, I'm going to put this one here and this one here. We're good. They're two different methods or functions. Here it's saying you've got the exact same code. I'm not sure what to change. So you can say, accept your current change, accept both changes, or you can just modify it and delete it manually. And Bob likes to be called Bob. So I'm just going to delete the text and keep Bob in here. Save it. And now commit the changes. And then it automatically created a comment saying that, hey, want to merge it, git push. So in worst case scenario, if you're in an irrecoverable state, go back to the comic that I just sent you, which is that no idea. If you're in an irrecoverable state, save your work somewhere else, trash your file, and download the copy from the source. Don't think about it too hard. Okay. So, and now I was able to push it. And now if we see we see that the merge happened. And if we look at our repository history, we've made all these changes and they're all snapshots of our code. It allows us also to see like when things happened, and keep track of who's done what. So I said this was the hard way. What was the easy way? I'm loading my GitHub desktop over here. So I'm going to go ahead and get I'm going to go and hit File, Clone Repository. Where do you want to get it from? Well, github.com. And since I'm signed in, I'd like it from one of my repositories. Specifically, I want, which repo do I want? I want the fall 2021 example. Over here. So click on that, and I'm just going to click clone. No need to remember what the command line commands were. And where it did is that show and explore is that it created this in my documents, GitHub, and then there. So I have another copy, but that's fine. I don't need this one anymore. I can delete it safely. And I know I can delete it safely because guess what? I uploaded it online. Okay. But here it is. Now, should you clone after the changes? All you have to, you should commit. Cloning is what copies it locally. So here, I'm going to just edit this and show you how it works. Hello world. I'm going to save this file. And now I'm going to go back to the GitHub desktop to show you how it works. So here it's detected there's been a change made to the Tetris with space lasers. changed, and I'm going to put in changed the hello world. Sorry, change the print to be extra good. Yeah. And then I hit commit to main, which basically commits the change. And then to update it, I hit this button. And it tells you about those things to do and says, there you go. And then if I need to pull from the internet, I just hit this button. And it will tell you if there's work that's been changed. So to get this, you can just go to GitHub and go to, you can get GitHub Desktop. From desktop.github.com. It will detect what you're using and you can download it automatically. So either way, you can use the command line, which I do recommend that if you are comfortable with working with the command line. Or you can use this. Because Git can be a bit finicky sometimes. But here's the thing. You need to start accounting for Murphy's Law as a programmer. It's very important that you account for Murphy. For those of you who are unaware, Murphy's Law states that whatever can go wrong will go wrong. It's an important law. So, you know, stuff like a hardware issue and your computer crashing or your little brother spilling chocolate milk on your computer, that's Murphy's Law in action. This means that you don't never have to worry about your code. Part of what you should do, and this is my personal advice to you, not related to just computing, but like to just in general your academic life, is to get to a point where someone can destroy your computer and that's not going to impede your work for more than a few hours if you had access to another computer. So I've gotten to a point where I can wipe all the data on my computer and I can be up and running by the next day. And not have to worry about any of the data that was on my computer originally, because all the important stuff is in the cloud.
So is
Just
GitHub
simply putting it on somebody else's computer. Yes.
is GitHub just a glorified Google Drive or Dropbox or whatever you want to call it?
No,
OneDrive?
because it tracks the changes and you can do multiple branches of the changes. So there can be different versions of the same file.
Gotcha. So in case there's like an error in one that totally screws everything up, you can always revert back.
Right. But not only that, like your work, if you're working on one, if you split up your work to like do different functions, any errors you make for your function won't affect what they're doing in their copy. And you can, and when you get both working, you can merge those changes together.
Yeah, that's pretty cool.
Using GitHub is the big way to do big team projects. If you want to, if one of the ways you can, if you want to try to stand out, is find a open source project that aligns with your interests, reviews, and then make what are called pull requests, which are suggestions for changes. Like, I made this change. Could you make a commit to it? You know, can you add it as a commit? So it's a very cool tool. Now, if you were here, like if you were in my office, sorry, if we were on campus, I have like a bunch of goodies that GitHub sent me because I asked them to, and they just like with directions and stuff. But we're in a pandemic, so I don't know. I need to figure out a place to leave them out or something. These things especially, the GitHub cheat sheets. I'll find out a place to, if I can leave them out. But these are useful. But most of these can be found online. The technology itself, Git, is an open source technology. You might have now if you have doubts about Microsoft and its reliability when it comes to open source software, noted. That's okay. You don't have to use GitHub. There are other Git services out there. But the point being is I don't want you to have to deal with like, oh, my computer crashed. And also just having a GitHub account basically creates a way for you to create a portfolio for yourself. That is how one of my friends ended up getting hired by Google. He got discovered by some of the work he did on GitHub. A recruiter reached out to him. So, you know, it's a good way to do something. Okay. It's again, one of those things that you understand more how you use it, the more you understand it, more how you use it. And it's integrated with a lot of development environments. Play around with the command line. Use this. There's no reason you can't use both. I use this to store all the code I write. My dissertation is stored on the website on GitHub. You know, there's all sorts of things there. It's a good technology. Okay. So now to talk a bit more about what we can do with the final project, which I will be launching this part soon. So so your next lab, by the way, okay, the next upcoming lab, which is due November 2nd. Yes, I know that's quite, and I'll probably push Pig back beyond that because people need time on that. And I might devote some time talking about the Pig lab today. Okay. So all you have to do is fill out this form and put it on your GitHub. Sorry, create a GitHub account, create a repository that has this form filled out on it. That's it. Okay. So basically this entire lab is just making sure that you are okay, that you can get started using GitHub. Not that you know how to use it 100%, but that you can. And if you don't want to use GitHub and you want to use something like Bitbucket, that's fine, by Atlassian, that's fine. Okay. Next lecture, what I'm going to do is go over like different tracks. So if you have no idea where to start, I'm going to give you some starting points. Okay. As well as potential extra credit. Okay. Yes. Question. I understand you are probably just typing it out.
Quick question. Could I possibly do like a web scraper project for
Yes.
this? Okay.
That's great. Cool.
All right.
All right. So Pig, the way this is constructed actually is that you can probably make it so that everything works off of everything else. So for here, what you need to do is basically, make a function that deals with the fact that there's a role. And if there's a role of a 1, you need to treat that differently. So so now notice that this was in the Monte Carlo approximation. So hold at 20 outcomes. So given at a number of hold at 20 turns, report the estimated probabilities of scoring outcomes. Enter a single positive integer, creating with the number of terms simulated. So this is what it might look like. So the idea here is that an easy strategy for you to implement that for the AI to play this game is to hold at 20, which is that you roll the dice, okay? And right, if they get a 1, their turn ends, they don't get any points. But they roll the die and they don't bank until they don't bank their score. They don't stop their turn until they get to 20 or more points. Okay. So that ends up being a not too bad strategy because it works 40, they get 20 points 4% of the time, which is 1/5 of the way there for the game. And so what we have is this estimated probability. So how do we generate these? Right. So going on into this file, which I've been using on just simply put, right. What we can do is we can create a dictionary called outcomes. And basically we can use the previous one to automate a turn. And that will tell me how many points it got, right? And then hold at 20 I can say, okay, I can basically run this 100,000 times or however many to see what my outcome is. Does that make sense to everybody? Or did I lose people? It's entirely possible I lost people here. So what goes into the dictionary? Excellent question. What goes into the dictionary is the score and how many times I've seen it. So let's start at the beginning. Let's go ahead and do one automated, pig. Okay, one automated turnip pig. Let's do this. Not too bad, right? Which is def auto pig. Okay, so this is part one, right? So what we're going to do is for each line, print a line with roll and the random die value. After a pig roll of 1 or hold, right? So the user doesn't need to make any choices. Okay, so let's see what this is. So what we're going to do is we're going to have a total 0 in our roll is equal to, and we'll need to import random because we're doing things random. So again, the game of pig, the way it works is that you roll a die, your goal is to get 100 points. A turn is basically either until you stop or until you hit 1. So here I'm going to auto pig to 20. Let's call it auto roll to 20. So, and what we're doing here is that we're letting the computer just decide, I want to stop when I get to 20 or above. So roll is equal to random dot I think it's what random dot rand int 1 through 6. Okay, so let's see. So now let's see what we do here. While. So what I'll do here is if roll equals 1, that means that we basically lost our turn. So we say total is equal to 0. And then return the total just to end it. Else elif roll is elif else we add it to our total. Roll total is equal to roll total plus roll. Go. And now what I'm going to do is I'll just put that in a loop. While total is less than 20. Why don't I use plus equals? Because people forget that plus equals exists and ask me why I didn't, what is plus equals whenever I use it. So here, and then let's go ahead and just add our print statements, print roll colon, comma, roll. And then print turn total. And this is not the only way to do it, to do part one. There are many ways you can do part one. What did I forget? A colon. And oh yes, I should probably call it auto roll to 20. So there, I rolled a bunch and I got my rolls, and turn total is up. Turn total. So see, I got a 1, and so I got a 0 for my turn. Got a 1, so my 0 for my turn. And I got a 5, a 5, a 4, a 3, 3. So I got 20, and I stopped. Okay, so now I'm going to comment out the print statements because I no longer need them for part 2. Part 2 is saying, wait a second. So I do this strategy. What are all my outcomes going to be? Def. Roll to 20 outcomes. Okay. And now what I'm going to do is I'm going to create a dictionary called outcomes, which will store basically the key is going to be the score I get when I run auto roll to 20. And the value is going to be how many times I see that that outcome occurs. Okay. So, and I'll take in as an argument, num runs as the argument here. For in num in range, num runs. So the user is supposed to input their number. We can add that because input's the easy thing to add. I'm going to add it to the end because adding the user interaction makes it slower because I have to put in, slows down the testing. So what I'm going to do now is I will perform, I will figure out what the score is of that's for the turn, which by doing the auto roll for 20. So this will give me a number that's either 0 or 21 through 25. 20 through 25. So I'm going to figure out that score. And now I basically say, hey, have I seen this score before? If score in outcomes, okay. If scores in outcomes, if score, I'm going to go and say score not in outcomes. If we have not seen this score before, outcomes is equal to, outcomes for that score is equal to 1. We've seen that score once. Else, if I've seen it before, otherwise, if I haven't seen it before, I've seen it once now. Otherwise, I've seen it before, which means that I want to increase the number of times I've seen it by 1. Yeah, that's fairly straightforward. And now let's go ahead and I will return my outcomes, even though that's not going to be useful. So at the moment, because print roll to 20 outcomes. And now I have to pass in the number of times I want to run it, which will be 10,000. And so it says, hey, you got 22, 21, 0s, 20, 25. Those are your outcomes. So now we actually have to do something a bit better. So let's go ahead and say n is equal to 10,000 or whatever. I'll put in n over here. Outcomes. Okay, and then what I'll do is I'll say for and I could do this inside the function as well, but for score in sorted outcomes, print score and outcomes for that score. This won't give us the full answer yet, but it's close. The sorted, what that did is that it put it in order of the keys in order. And then to get the probability, I just divide by n. And we'll see that that matches pretty closely over here. So 3 is just doing the same thing, but we change our strategy. Rather than doing holding at X, we're going to do holding, rather than holding at 20, we allow the users to specify what the strategy is. If you hold to 100, then you should have a 99% chance of not scoring anything. Okay. And what these do, and so I'm aware class is ending. So what these do is eventually you build up to exercise 8, which is playing against the computer. Okay. And feel free to reuse your code for each part and put in multiple and make your functions reusable. So let me go ahead and stop sharing. All right, so class is dismissed. I will, if you were to demo it to me, I'll probably ask you about the 3rd part and the 8th part. Yes, you turn in all 8 parts. Let me go ahead and I will drop the code in chat. So hopefully this will help you get started on it.